Welcome back, ladies and gentlemen. Today, we are going to watch another video on the Katona's Tutoring Channel with your host, Mr. Katona. As you can see by the title, we are going to be going over scientific notation, specifically converting from standard notation to scientific notation. What is standard notation? As you can see on the board, what I put is 100, and I wrote standard notation next to it. Any number that you can think of, whether it's 100, 150, 500, 670, all of these numbers are written in standard notation. We have another way to represent these numbers, and that's in scientific notation. Now, why do we use scientific notation? I'll explain that later in the video. If we look at 100, which is in standard notation, there is another way to write it. We could actually write it as 1.0 times 10 to the second power. So 100 equals 1.0 times 10 to the second. Now, how did I do that? I'm going to show you. When we see 100, we can assume at the end of this number is a decimal, right? So we have a decimal point right at the end of the number, because if it was a decimal, it would be 100.55 or 100.672. So we have our original decimal point here, and our new decimal point is going to go in front of the last zero right behind the first whole number. So we actually move our new decimal point right between 1 and 0. And then we simply connect them. Oops. We go boop and boop. So as you can see, I had to move the decimal point once, twice to move it to its new location, which is where we get the exponent 2. We have 1.0 because that's where the decimal point should be now. And then we don't need both zeros because all we need is to show 1 0. And this is how we write 100 in scientific notation. Now, how did I know it had to be in between 1 and 0? How did I know how to do all of this? Very good question. How did I know that it was written at times 10 to the next power? That's a very good question. What I want us to do real quick is look at the rules for scientific notation that I wrote down on the board. Rule number 1, this number that we are creating has to be greater than 1 but less than 10. This means I couldn't have moved the decimal only once and written my fraction as 10.0. That is not allowed. It also cannot be 0.10. This also is not allowed. But 1.0 falls within the range and is acceptable. So now that I knew it had to be 1.0, I simply just had to put the decimal point where it belongs at the end and where it would be moved in this new notation. And then I just connect them, and voila. That's my answer. Lastly, if we look at rule number 2, our base, this guy right here where the exponent's raised to, always has to be 10. And if you would like a video of me explaining why, I could do that in a separate video. But leave a comment below if you would like me to explain why the base in scientific notation is always 10. But that's just one of our rules. So let's look at another example together on how to do this. So if I have 250, I need to remember when I create this new notation, I have to have a decimal that's in between 1 and 10, which means if I move the decimal point once to 25, that's unacceptable. If I write 250, once again, unacceptable. So instead, what I'm going to do is I know my decimal that I have to create will be 2.5. Now, what do? I will explain. So, as we talked about before, our decimal point in the beginning of this regular number in standard notation comes at the end of our number. So it would be like 0.0, 250.0, or even 250. And we know that our new decimal point must be right here, like we're creating our decimal of 2.5. So that means the point has to be in between 2 and 5. Because it was in between 5 and 0, we would create 25, and that's unacceptable. If the decimal stayed put, we would have 250, that's unacceptable. But 2.5, perfect, in between 1 and 10. Now, we have to remember to write times our base of 10. Now, what's our exponent? This is the tricky part. We have to count. 1, 2. We connect our decimal and then count. So it took us 1 line, 2 lines, 1 circle, 2. So this means our exponent is going to be 2. 2.5 times 10 to the second power. Voila. Done. Checks off. We're good to go. What happens if we have a number like 49,609? We're going to follow the same rules, but now we have a bunch of numbers in between. So I'm going to look. I have to always remember where my decimal place is. It's going to be always here to start. And now I have to create the decimal. Now I know it can't be greater than 10, so it can't be 49. It can't be 496. It also can't be 0.4 because it has to be greater than 1. So that leaves us only one option, 4.9. So our decimal that we're creating is going to be 4.9. So now we count. 1, 2, 3, 4. 1, 2, 3, 4. Now, can I just write zeros after the 9 like we have been for 2.5 or for 100? I actually cannot. I have to show the rest of the numbers in the original standard notation. All the significant digits, which means 9, obviously, 6, and because 0 is in between two significant digits, we have to write 0, 9. So our decimal we create actually has to be 4.9609, because again, our 0 is in between two other significant digits. So now we have our decimal. Our decimal agrees with the rule. It's greater than 1 and less than 10. And then we obviously have to write times 10. And then we have to write the right exponent. So again, we connected 1, 2, 3, 4. Exponent 4. Voila. Now, why are we going through all the trouble to learn this? Very, very good question. What if I had 7, 5, 6, 5, 4, 2, 0, 5, 0, 0. 7,565,420,500. Do you want to write this number all the time if you had to write it 5,000 times? No, neither would I. So we have scientific notation to compress large numbers. What we're going to do is follow the same rules. I have to create a decimal in between 1 and 10, which means most likely my decimal point will end up in between 7 and 5, so I have 7.5. And we know in the original number, in the standard notation, the decimal is at the end. So now, let's write our decimal. We need to do 7.5654205. All significant digits. The rest of zeros are not significant because they're after the significant digits. Boom, 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 times 10. We can't forget to write the times 10. And now let's figure out our exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So our exponent will be to the 9th power. And that is writing scientific notation with large numbers, with positive numbers. Because of time, and I want to keep videos as short and sweet as we possibly can, I'm going to create a separate video showing how to go from standard to scientific notation when we have decimals. It's a little bit different, same idea, but it's a little bit more complex, so I want to save that for a separate video. I will also make another video showing how to go from scientific notation, which is what we have here, to standard notation, which is what we've been starting with. So there's 2 separate videos that are going to come out showing these different types of conversions. With that being said, if you liked this video, please leave a like. If this video helped you, please leave a like. If you want to see another video that I haven't posted yet on a topic that you're confused with, please comment that topic below and I'll try to create it as soon as possible. Third, if you can share this video and this channel with people that you know that might be struggling, we would very much appreciate it. We're trying to reach as many people as we can, as many students, adults, anyone who needs help, and reviewing, learning, etc. Lastly, if you live in the state of New Jersey, or you want online tutoring, or you would like in-person tutoring, please email the link in the description, katonastutoring@gmail.com, and we will get back to you as soon as we can, and we'll set up sessions. The first session is going to be free. You get a free 30-minute consultation where one of our tutors works with your child or works with your student, and we determine where they could use help in said subject, and then we set up a plan. Again, if you would like tutoring, online or in person, please email the link in the description, katonastutoring@gmail.com. Thanks, guys. Have a great day.